Hi all, I am Anishma A, Assistant Professor at the IISA Institute of Technology. I am here to give a technical talk on self-filled concrete pavement. Nowadays, most of the low-volume village roads are being constructed by using flexible pavement with thin bituminous surface. So often these roads get damaged due to the overloaded vehicles, inadequate drainage facilities and water logging problems. So that itself it requires periodic maintenance. So the IIT Karanpur developed a technology known as self-filled concrete pavement. It promising solution for these issues. So it provides long-lasting concrete pavement with low initial cost and also maintenance free. This also generates employment opportunities in rural areas. This is the figure of self-filled concrete pavement. Now we are moving on to the components of the self-filled concrete pavement. The first one is plastic. It acts as a form and also as a reinforcement for the pavement. It is made up of reclaimed high-density polyethylene sheet of thickness 0.22 mm to 0.25 mm. These plastic cells are supplied as roll of strips of 50 mm to 100 mm wide depending upon the depth of the requirement. The strips can also be heat welded or stitched to form cells. The second component is the subgrade. The subgrade forms the top 300 mm thick portion of the embankment. Embankment subgrade is compacted in two layers, usually to a higher standard than the embankment. If the embankment soil is poor, the top 300 mm of the subgrade may consist of good quality material from borrow pit with CBR exceeding 5. The subgrade shall be compacted at least 100% of maximum dry density according to the IS 2729 Part 7. In the case of expansive black cotton soil, it should be compacted to a minimum of 95% of maximum dry density with moisture content 2% higher than the optimum. The third component is subbase. The subbase consists of different types of materials such as laterite boulder consolidation, water-bound macadam, wet mix macadam, crusher run macadam, lime fly ash aggregate mixture, lime stabilized soil, cement stabilized soil and other with properly stabilizers. And also locally available aggregates can be used such as moram and kanker which is mixed with the lime fly ash. And also the locally available materials such as natural gravel soil aggregate are blended with the suitable aggregate fractions of stone, gravel, moram, sand or a combination of these materials can be adopted depending upon the grading required. The fourth one is concrete. Conventional pavement concrete with 28 days strength of 30 MPa with a slump of about 30 to 50 mm can be filled up the cell. Superplasticides can be used to reduce the water requirement for the desired slump, and the roller compacted concrete are specified in clause 1502 of the specifications for rural roads can be used for filling up the plastic cells and compacted with a roller. Now we are moving on to the construction procedure of self-fill pavement. The first step is construction of embankment, subgrade and subbase should be done as per the specification for road, and next one is the application of camper and drainage according to the rainfall areas. Third one is the stone concrete block or brick on the end edge of it should be laid on either side of the carriageway projecting 50 to 100 mm above the subgrade or subbase from the confinement and protection of self-filled concrete. And fourth one is a hardened shoulder with a proper cath is necessary for the concrete block for the stability. Fifth one is the width of the hard shoulder should be about 0.8 mm on either side. Sixth one is the Formwork of plastic cell shall be laid across the compacted subbase and put under tension with iron spikes so that the cells are closely to squares in plan. Next is nylon threads passing at 10 mm below the top of the cell shall prevent the cell from collapsing while filling the cell with concrete. And eighth one is if any stitch of the cell opens up during tensioning, it should be stapled near the top, middle and bottom. And ninth one is the concrete shall be filled into cell to a depth of 120 mm, which is about 20 mm higher than the cell depth. And the 10th step is the iron spikes shall be removed after the cells are filled with the concrete. For RCC, 2 passes of rollers in static mode followed by 2 passes in vibrator and other passes in static mode shall be sufficient compaction and a good finish. And the 11th one is the number of passes of static and dynamic mode depends upon the texture of aggregate and moisture content. 11th one is pan vibrators can adapt to compact. 13th one is the number of rollers passes, the amplitude of vibration and the depth of those concreting cells and the amount of water to be added shall be determined from the trial run. The concrete surface shall be covered with the wet jute mat or paddy straw to prevent drying during the hot weather. These are the steps included in concrete self-filled pavement. This is the laying process of self-filled concrete pavement. Next, the advantages of self-filled concrete pavements are it can be recycled plastic as the expansion and contraction joints are not required and hence maintenance of joints is eliminated. The cost of construction is considerably reduced when compared to the conventional method, and the consumption of aggregate is almost reduced to 50% when compared to the normal concrete pavement. If the individual block fails, it can be easily replaced with without much effort with the least cost. And the disadvantages of this are the preparation of cells is difficult. There are high chances of cells getting disturbed while placing the concrete and hence proper care is required. Due to the slow progression, the men and machinery efficiency is less than the normal construction. So this is about the self-filled concrete pavements. Thank you.